In this video, we are going to do the first thing that you might do after installing Voyager. Actually, the first thing we recommend you do, which is to run through the quick start tutorial, which is outlined on the wiki at voyager.tourstar.net. Again, we highly recommend getting familiar with and bookmarking the wiki, as most of your Voyager questions are answered there. So, on the wiki, if you scroll down on the left, you'll see Tutorials as a category. Click on Quick Start, and that loads all the instructions you need. So you can actually stop the video now and just do it by following the wiki, or you can watch the video where we will lead you through the steps. So, to begin with, you should have installed Voyager already, and we have done that. Make sure that it runs, and up it comes. Okay, so Voyager has started. We are ready to begin the Quick Start tutorial. And the first thing we're going to do is create an empty profile. So in Voyager, you have the concept of a profile. You can create as many profiles as you want. And a profile is where Voyager will store all the information about your configured equipment, software, and statistics that are collected as Voyager runs. And with time, those statistics allow Voyager to get more accurate about estimating the amount of time a sequence will run. It allows Voyager to improve autofocus, many other things. So on the Profile tab, which I've just selected here, you see that you can open a profile, pick one off of disk, actually have the empty profile that is saved. You can save the active profile, though you don't really need to manually save your profile. When you make changes, they are automatically saved for you by Voyager, which is a very nice feature. You don't really need to think much about profiles other than to make sure you have the correct one loaded. If you're going to make changes to a profile, you could open an existing one and then do a save as and give it a new name. And save the profile that way, basically creating a copy of the open profile. If you want to clone one off the disk and then modify it, there is a clone operation. So we can pick a profile off the disk and open it and then give it a new name and have use the clone button to create a new one. Or we can create a new profile from scratch. So that's profiles. That's really all you need to know about them. As you use Voyager with different hardware, different software, you'll get in the habit of creating a profile for each configuration. And then as long as you remember to load that profile at the start of your session, that's it. You really don't need to think a whole lot about profiles, which is quite nice. So we've created a profile, and the next step is to create a camera definition in the Setup panel. So you can get over to Setup by clicking on the Setup button in the Section ribbon. You can also get there by clicking the little wrench and screwdriver icon up on the top of the window. And the very first tab in the setup form is where you set up a camera. So click that if it's not already clicked. And from this drop down we will pick ASCOM. So what we're going to do is set up just a very simple profile using the simulators that ship with the ASCOM platform. So you have to install ASCOM to use Voyager, and you will have these simulators installed already. And this will let us do just about everything you can do with Voyager without having to waste valuable imaging time, waiting for a clear night, or even hooking up your equipment. You can just do it all with the simulators. So we've picked ASCOM as our camera type, and then we click this button that has ASCOM on it, and that will bring up the ASCOM camera chooser. You probably have two choices there, version 2 and just plain simulator. I use the version 2, it has a little more flexibility. And then we click the properties button, and here you can put anything you want in here. What I like to do is put in settings that mimic a camera that I use. So I've decided to use the settings that are similar to the ASI 1600 mono-cooled camera, one of my imaging cameras. And for that, We have the pixel width and height. You can get these from your camera maker's website. There should be a specification panel that has the pixel width and height information. Maximum ADU, so this is the value returned for a completely filled pixel in the camera using 65/535. The width and height in pixels of your CCD. What type of camera it is. The ASI 1600 that I'm emulating is a monochrome camera. Whether it has a cooler, can you set the temperature, can you get the cooler power? I have all those boxes checked for my simulator. It uses gains. Set the exposure, min and max times. And if you want, you can pick an image file. This will just be a single file that will be returned every time you tell the simulator to take an exposure. So it's of limited use. Click OK. Click OK in the camera chooser, and now we have our ASCOM camera set up and selected. There's also a few things that we want to set in this panel to get things working properly with the simulator. You have to pick a telescope focal length. I picked 840 millimeters, which is what my Esprit 120 refractor is. You can put in a value there for whatever you like. Since the pixel size, I believe this is picked from this camera definition, but double check that to make sure your pixel size is correct. And then Voyager will automatically compute the image scale for you. Also pick your sensor type, monochrome in this case, and whether you want the cooling, the simulated cooling system, if you have one, to automatically turn on when you connect, and I have that set up to on. Then there's some values here. The timeout for waiting for the temperature to reach the value that you set as the default. I put minus 15 degrees Celsius as the target value for my simulated cooler, and I've set 7 as the number of minutes I'm willing to wait for the camera to reach that temperature. Deviation max also says at what temperature value do you consider this cooling temperature to have reached equilibrium. So I put a pretty wide number here, 1.5 degrees centigrade, because this is a simulation, so I'm less critical about how close it gets to the desired value. I also have a default cool down time. I picked 5 minutes here. We also have a for the deviation max, I should have said it's 1.5 degrees Celsius and a time span of 60 seconds. So that says as long as the deviation is within 1.5 degrees over a period of 60 seconds, we consider the temperature to have settled. And for most of these, you can pick the defaults. Temperature control allowed by camera is checked. And over here, shouldn't have to change any of these. The default setting should work. Speed, the default setting should work. So that's it. So at that point, we've got the camera set up. Next, we'll set up the filter wheel. And next, we're going to configure the filter wheel. So again, we're going to pick ASCOM as our filter wheel type. Bring up the ASCOM filter wheel chooser and pick the simulator. I've had better luck with simulator than with the .NET version of the filter wheel simulator, so you could try both, but I've had some problems. Just recommend using the simulator. That seems to work. And then you can configure again this to match your own hardware if you have a filter wheel, so that when you run the simulator, the settings will be familiar and similar to what you get when you're live with your own equipment. So I have a ZWO 8 slot filter wheel. So I pick 8 as my number of filter slots here. Half second as the time it takes to change from one slot to the next, and then my filters that are loaded by slot. So I have my luminance, my red, green, blue, sulfur, hydrogen, and oxygen, and a dark in the last, or the 8th slot here. We're not using focus offsets, so I have all these just set to 0. And you can pick the colors by clicking on any of these to match what you'd like to show when that filter is selected. So that's a good idea to use choices here that make sense for you. I've got a red for red, green for green, blue for blue, etc. I also have that this implements filter wheels and implements focus offsets, always on top is up to you, and click OK. Click OK on the filter wheel chooser. And unfortunately with the simulator you can't just click get. You may be able to with your live equipment be able to get the results. So we have to go into the edit screen here where we can set our filters. So filter number 1, we're just going to match the values that we had for in the filter wheel. I had LRGB and SHO, and I had a dark for the last one. And then over here we're not going to deal with any of this right now. These are all autofocus configuration parameters, and we'll worry about that later when we do the autofocus tutorial. Click OK. Now our filters are set up and we're ready to move on to the next step, configuring the mount. The last piece of equipment we need to set up is the mount. So click on the mount button in the setup form. And again, from the mount drop-down, we'll pick ASCOM. Click the blue ASCOM button, and we're going to pick the simulator. Click Properties, and here you can use the settings that I've entered, which will make your quick start tutorial results be the same as in the wiki, or you can set your own latitude, longitude, and elevation. You definitely want to set this site information to match the site where you are running Voyager when you hook up your real gear. Or in many cases, your mount itself will return the latitude and the longitude if it has a GPS, or you may be able to set that in the mount's ASCOM driver. So, bottom line, the mount ought to return the correct site information, or you can set it here. Were you going to simulate a German equatorial mount? These optic settings, I believe, are optional, and you can choose whether to auto unpark, track on start, disconnect on park, but those are all optional. Click OK. Click OK again, and we're pretty much done. We'll take a quick run through some of these settings. Settling time of 2 seconds, so that says how long to wait after a slew. We're not going to be doing any precision pointing with the simulator because plate solving is not possible without a real view of the sky. We have unpark and track on connect checked, which are good settings. The Meridian Flip Manager, we're going to be using the scope position to determine our ASCOM peer mode. We could also get it from the ASCOM driver, but for now we'll just go with scope position. And the rest of these settings we can leave at the defaults. And that looks like about it. So that's it for setting up our profile, and as you recall, our settings have been automatically saved by Voyager to this empty profile. If we want, we could go over here now and say, let's save this as our quick start tutorial profile. Yes, replace it. So now we'll be running with that. And that's it. So in the next step, we're going to use this profile and this simulated equipment to simulate taking an exposure and moving the mount around. Okay, so now we have defined a profile and we have set up a camera, a mount, and a filter wheel. And the next step is to connect to them. So from the section menu, click the startup icon. That'll bring you to the startup workspace, and this is where we do our connection. So click the connect button and it will bring up each of these devices in turn and form a connection from Voyager to them. While we're waiting for that to happen, over on the left you see the names of all the devices that the types of devices that Voyager can connect to. Everything from the camera, filter wheel, and mount to guiding, planetarium, plate solving, blind solving, and etc. here. In the middle you see the current device that's configured for each of these categories. And once we've connected, we get a green indication here. If you hover over it, you'll get a little bit more information that tells us more about the specifics of the driver that we have connected to for each of these devices. If you get a red message here, it's an error condition telling you that the connection failed. and usually it'll give you some helpful information that tells you what you need to do to correct it. What I've found in most cases is either powering down, powering back up that device so that it can be connected to solves the problem. It's typically something down at the USB level that hasn't connected properly yet. So Voyager needs you to reset before it can connect. Once it's connected and you're all green, you're ready to move on to the next step. So for our next step, let's get familiar with what we have in front of us in the on the desktop here from Voyager. We have two important areas over on the right. We have a status and a commands window, set of windows. And the commands window is where you can issue immediate commands like parking the scope, turning tracking on and off, homing the scope, setting the cooling point for your camera if you have a cooled camera. And there are more options here if we had more devices configured, but since we only configured a very simple set of devices here, these are all currently not displaying any information. But if we go to the status window, we'll get a little more information. We have up here the current operations. The mount is green here, which in the tracking window, which tells us that our mount is tracking. When it is slewing, calibrating, guiding, focusing, etc., these little LEDs will light up, giving us some indication of what is happening with the mount currently. Next step down gives us where the mount is pointing. So we get local sidereal time, RA and deck, azimuth and altitude for where the mount is pointing, whether we're east or west of the pier. So right now we are east pointing to the west. And our current local time and the time to the meridian flip, which in this case is negative, so it's past given where the scope is currently pointing to the west. Autofocus we haven't talked about yet, so that's off. CCD cooling, you see a graph here showing you that currently we're at 12.5, minus 12.5 centigrade, and our set point is minus 15, so that's where we're headed to. The simulated power consumption is already 94%, so for this particular simulator, it's taking a lot of power to get down to our desired set point of 15. We haven't yet defined the target or the sequence information, so these fields are not, or these status windows are not currently showing anything. So that's the status window. Next, we will move over to the on-the-fly workspace and do some operations. Okay, we have our equipment connected, our simulated equipment connected to Voyager. Now let's move over to the on-the-fly workspace. We click the on-the-fly icon in the section ribbon, and here the first thing we want to do is enter a object name in the name box, and we want to find its coordinates. If we had configured a planetarium, we could use the fast find or this more detailed find button, but since we don't have a planetarium configured, let's use Simbad. Simbad is an online free service that will look up an object name and return the RA and deck coordinates, which it very quickly did here. You have to have an internet connection for this to work. Click OK and the coordinates get entered into the RA and the deck boxes here. We can do things such as slew them out by clicking the Go To button, and if we confirm that, look over here, we'll see the RA and the deck coordinates advancing as the mount is being slewed to M97, the Owl Nebula. So we now have the mount, our simulated mount, pointing at M97. Let's take a picture. If we just wanted to take a single picture, we could use the camera shot action. If we click the gear icon to configure it, let's go ahead and use the blue filter. We'll take 5 exposures, binning one by one. Full frame, we could choose a subframe here. Click OK to accept the configuration, and then click the camera shot. And if you look down in the monitor window, you can see exposing 5 seconds, blue filter, type equal light, binning 1, exposure finished, download started, download finished. And all the operations being done by Voyager to achieve that camera shot are very nicely listed here in the monitor window, so we know exactly what's going on. So now we have shown how easy it is to enter in a target name, find the coordinates, and take a picture. What if we want to take a sequence of multiple images? Let's do that in a moment. Was taken. So let's say we want to do more than just take one shot on the fly, but we want to create a sequence. And to do that, we go here to the session area, click on the gear next to the sequence button, and that brings up our sequence configuration dialog. Our coordinates for M97 are already loaded for us because that's what we had configured as the target in the on-the-fly workspace. And we have here the profile that's currently in use, which by default will be the profile that was active at the time you brought up the sequence configuration window. And then we have a number of slots where we can define our exposures on a per filter basis. So let's start by clicking on the 1 button here, which says we're going to activate slot number 1. We're going to take a light frame, and we're going to use the luminance filter. We're going to take a 5-second exposure, binning of 1 by 1, speed default, readout mode default, and we're going to take, let's say we want to take 5 pictures, each of 5 seconds long. And that's it. So now if we move to the next bar here and we want to take something with the red filter, say, and perhaps we want those to be 10 seconds, default, and 5 exposures. And then now that's been defined. Let's take a green filter shot next, 10 seconds, 5 of those. And we'll finish up with a blue sequence, also 10 seconds, and 5 shots. And notice I'm not bothering with the speed and the readout mode because for our simulated camera and for the camera that I use in real life here, these are just the defaults, so I don't even need to set those. Down here now we see what's called the synoptic bar, which shows us a color representation based on the colors that we set back when we set up our filter wheel. Of the length is equal to or proportional to the total number of seconds taken for that filter in sequence, and the color represents the filter itself. So here we have white representing our L, our luminance filter. Short, since these are only 5-second exposures, this will be half the time of the red. Equal length, red, green, and blue, and now we're seeing it repeat. So what is that telling us? Well, we actually have a couple of different modes we can run our sequence in. Cyclic round says take one picture from each of these rows and then circle back around and take the second picture. So we would perform 5 complete cycles around through the filters, LRGB, 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 etc. And if we count here, we see 1, 2, 3, 4, 5. So in fact, this is repeated 5 times. If we wanted to take all the pictures with each filter before moving on and changing the filter, which is more commonly the case because you probably don't want to spend the time changing the filter and refocusing for only a single shot. Now we get a sequence here of all the L's, all the reds, all the greens, all the blues, and it's only going through one time. But let's say we were at a dark site, we wanted to make sure that we got some pictures with each filter. So we didn't want to wait too long before changing filters in case clouds came in, but we also wanted to get more than just 5 shots with each filter for the course of the evening. Well, then we could check the repeat button here and increase the number of times that we run through the filters. So I've done it 4 times here, so now if I ran this sequence I would get 20 shots with each filter, but it would take 5 luminance, 5 red, 5 green, 5 blue, and then it would move on and do the same thing over again and repeat that whole sequence 4 times. Sequence directory we're leaving to auto here, so this is another thing that is set up in your configuration area where it's picking a directory to save my shots to. I can say create a logical folder inside of this folder, so it'll create a folder named with today's date or the date that the pictures are being taken, and so forth. So since this is a quick tutorial, we're going to take defaults for everything. We'll have a tutorial about configuring the sequence where we go through in more detail what you can do on each of these tabs, but you can click through them and most of this is self-explanatory. But this lets you configure everything about running the sequence, from the temperature to cool the camera, to pointing, tracking, plate solving, meridian flip, your guiding settings, how you want to wait or redo a shot if there's a problem, all the options for autofocus, and what to do in case of an error and when the entire sequence finishes. But for now, let's just click OK. And I should mention before we exit here, if we wanted to save this sequence, we can go and click the icon up there and save this. Let's say M97 simulator sequence. Click OK, and now this sequence can be recalled later and run again. So that was this little disk button here that I clicked. And if we wanted to load a sequence, click the icon next to it and pick the sequence and load it. And we could reload the same one that we just ran, that we just saved to disk, and there will be no changes. Click OK, and to run the sequence we just click the sequence button, confirm, and then watch in the monitor window here as we get information about the sequence that is running. So it tells us in blue here that it's taking an exposure, how long it's for. We did not set up cooling, so no cooling is currently configured. And it will continue to go through the sequence, running it and showing us in the monitoring window what's happening until it finishes that entire sequence. So since that entire sequence is going to run for quite some time, we could click abort here and just stop the sequence. Let me show you as well here a monitor window where we can do things like pause the sequence. So now we've paused and it waits until the shot is finished, or we can click resume and we'll take the next shot in the sequence. We'll let that one finish and then we'll hit abort, and that will be it for our tutorial. So it's downloaded, and if we hit the abort button up here, it's going to end our sequence, and that's it. So now you've seen in this quick start tutorial we have talked about profiles. We've done some simple setup for a camera, a mount, and a filter wheel. We've found a target, found its coordinates. We have slewed to the target. We've taken a single shot and we've taken a sequence of shots. So that's quite a bit of ground covered. You could now go back and redo this sequence with your real equipment. Set up your real camera, your real mount. If you have a filter wheel, set that up too. And at this point you could, under the stars, run Voyager, watch what it does, and take some shots. There's obviously a lot more to Voyager to go through in subsequent tutorials, where we'll talk in a lot more detail about things like autofocus, plate solving, guiding, meridian flip management, and then it's kind of the crown jewel of all of this, the automation editor called DragScript, where you can program your night from sundown to sunup and get things running so that you can just click a button and Voyager will take care of things from there. That's it for now. Hope you enjoyed the tutorial, and we will see you in the next one. Bye-bye.